Okay, hello, you're most welcome once again to my channel. It is still your tutor Peter Ekaja, and in this video today we are going to be talking about the Tane substitution, having summarized the sign substitution in our previous video. Now, this video will basically benefit the advanced level students who are offering mathematics as part of their combination. Now, without wasting a lot of time, I want us to begin by now knowing the difference between the sign substitution in the previous video and the Tane substitution. First of all, the main difference is in today's video, we are going to be handling integrals of this form that I've just underlined here. We're going to be handling integrals of that form. Integral 1 out of a squared plus b squared x squared with respect to x, where a and b are constants. Now, something to note is that even for today, we shall say to integrate functions of the form 1 out of a squared plus b squared x squared, we make a substitution. A squared plus b squared x squared is equals to a squared plus a squared tan squared of u. I've just decided to use u as my new variable, but someone else can use any other variable, but I've taken it as a choice. Again, you're going to realize that I've just maintained this constant a squared, and that is what I have here as a squared plus a squared tan squared of u. So that is going to be the basic trick here, and it will help us in a way that now when you proceed and compare these two expressions on the left and on the right hand side, a squared can easily cancel. We remain with b squared x squared equals to a squared tan squared of u. Now when you take a square root on both sides, remove the squares, you basically remain with bx is equals to a tan of u. And from here, you can decide to either differentiate directly or make x the subject. So if I made x the subject, then I'll have a over b tan of u. And then from here, we shall do the differentiation, find out the expression for dx, and then later on, as we introduce a new variable, as we introduce a new respect of integration, where there is dx, we shall put its expression that we obtain after differentiating this with the respect to u. Now, we should also not forget that at some point we shall be required to express u in terms of x right away from this statement. Basically, if bx is equals to a tan u, then we can easily see that if I made tan u the subject first, it would be bx out of a. That means u alone would later be expressed as tan inverse of bx, but divided by a. That is something that we shall apply at a later stage as we look at our examples. Let's move direct our examples and proceed as follows. Okay, that is our example number 1. Example number 1 says we find integral of 1 out of 1 plus x squared with respect to x. Now, what we can basically do here is to maintain the fact that we shall let 1 plus x squared to be equal to 1 plus tan squared of u. Remember, the constant term here is 1, and actually I maintained it here, and I've also maintained it as the coefficient of tan squared of u. When you compare, you basically realize that x squared will actually be the same as tan squared of u. And therefore, when you take the square root on both sides, x becomes tan of u. Now from this level, you now differentiate x with respect to u. That means I can look for dx du. That means it gives me sec squared of u. And if that is the case, I make dx the subject, and therefore it will be sec squared of u du. Then from this level, I know that I can now come and proceed smoothly by saying integral of 1 out of 1 plus x squared with respect to x is going to become integral of 1 out of, where we have 1 plus x squared, we committed ourselves clearly here. We said the whole of it is equals to 1 plus tan squared u. So I will say 1 plus tan squared u. And then where there is dx, we write sec squared du. But remember, sec squared du in this case is also as good as 1 plus tan squared u from one of the identities of trigonometry. That means ideally our dx can be modified to that, and therefore it will be easy substituting that 1 plus tan squared u, so that we see easily that 1 plus tan squared can cancel with 1 plus tan squared as the denominator here. And so when they cancel, we remain with the integral of 1 du, which gives us basically u plus the constant. But remember, like I said, u now must be expressed in terms of x, so that as we make our clear conclusion, integral of 1 plus x squared dx now becomes u, but which is going to be obtained from this expression. Take that point seriously. From this expression, u definitely becomes tan inverse of x. So the answer will be tan inverse of x plus a what? Plus a constant. And we said that constant is always an arbitrary constant of integration. So this is basically how you would approach such a simple question. And from this, I will take you right away to example number 2. Okay, now for number 2, they're telling us to find the integral of 1 out of 3 plus 4x squared with respect to x. Please, you just need to know the form. We are still maintaining our form, and that form, as I talked about earlier, I said must strictly be of the form 1 out of a squared plus b squared x squared with respect to x. So look at the characteristics of this function we are integrating. They must conform to our question before we apply this technique. So in this particular case, we would say in our solution that yes, we would first let our 3 plus 4x squared to be the same as, remember the constant is 3. So I maintain the 3, I say 3 plus 3 tan squared of u. When you compare the terms, the 3 cancels out, so you remain with 4x squared is equals to 3 tan squared of u. And then from here, take the square roots on both sides. You will get a 2x, and this side you will get root 3, because 3 is a non-square number, but you remain with only tan u here. You can differentiate directly, or you first make x the what? The subject, so that you have x as root 3 out of 2 tan of u, which is our suitable substitution now. And then definitely the x du now becomes root 3 out of 2 sec squared u. And this gives an implication that if you make dx the subject, dx becomes root 3 out of 2 sec squared of u du. Then we get back to our function, the original function. We are now going to say integral of 1 out of 3 plus 4 x squared with respect to x is actually the same as the integral of 1 out of, where there is 3 plus 4x squared. Remember, we made a commitment at this level. made a commitment, and we said it is the same as 3 plus 3 tan squared of u. Where there is the x, now we have root 3 out of 2 sec squared u du. But now remember, we can all see that 3 plus 3 tan squared u, which is our denominator here, has a common factor 3. I will pull it out. When I pull it out, I will realize that actually I have integral of 1 out of, this is a 3 into brackets 1 plus tan squared of u. But remember, we also have a root 3 here. I'll be patient with it. Out of 2, sec squared is the same as 1 plus tan squared of u with respect to u. Then what do you now see? You will now realize that we shall have root 3, which is a constant, out. I have a 3 by 2, which is a 6. So it will be root 3 out of 6. 1 plus tan squared and 1 plus tan squared can cancel out. So we remain with integral of 1 with respect to u. The respect to you. Now, from this level, I can actually conclude that our integral of 1 out of 3 plus 4x squared with respect to x will now be, it would be root 3 out of 6u. But our question was in terms of x, so I will express u back in terms of x. How? I get back here to this step. I say if 2x equals to root 3 tan u, then tan u is 2x out of root 3 first, implying that u would be tan inverse. It would be tan inverse of 2x out of root 3. That means the right answer would be root 3 out of 6. Then I say tan inverse of 2x, but divided by root 3. Divided by root 3, and then plus our constant of integration. This is how easy Tane substitution is. You realize the steps are really very simple to follow. And in case you find a challenge, we are always there to help out. So let's move direct and add on another one example. And then later, I'll give a few questions for you to try out.